Hello guys, this is Lin Yizhen. I'm the team coordinator for this kind of project. And I'm working on the parallel programming code part and the ARM assembly.
I worked on the report and the Parallel 3 programming basics.
Hi, I'm Aaron Portal. I worked on the Task 3 questions section as well as the ARM assembly programming.
Hi, I am Woody Montalis, and I was in charge of some of the Task 3 questions as well as the video editing.
Okay, so what we have learned this time from the project?
Something I learned was kind of how the race condition, parallel programming, as well as dependency, how they all kind of fit together and work. Because most programs in general have a dependency, which dependency is when you have one section of the program that relies upon another section of the program. So you have a section that passes in whatever variable that can change due to that method somehow. So this relates to parallel programming because parallel programming, it's difficult to get that to work with dependency because you have different areas of the programming running and you have to make sure that there's no dependent variables that will cause a bug. And if there is a bug, this is actually called a race condition. Based on the timing of the dependency, basically you might have several tasks going in a sequence, but if one of them, due to the dependency, doesn't finish itself because of the dependent issue, it has to wait longer for whatever reason, this can become a race condition. So it's interesting how these all fit together and how they rely upon each other and how you have to consider this when you're designing a parallel program. You have to keep this in mind to make sure that it'll work out correctly. Otherwise, you'll be left with a race condition, which is a very difficult bug to fix.
Sorry. Generally speaking, on the parallel programming part of this, what we understood when we were working on this project, what we learned and what we were able to really connect with were the idea of patterns. As computer scientists, it's really important for us to optimize, to learn how to figure out a problem and to make it easier for us to deal with that the next time. So the idea of patterns was one that came naturally to us. The idea that there is a way, there's a system, there's basically a template for us when it comes to parallel programming that makes it easier for us to understand how to use the programs and what kind of programs we need and what kind of syntax we need to handle that. So the idea of patterns falls into two different subcategories, where one is the strategies and the other one is the execution mechanisms. And whereas the strategies are completely based on you, regardless of what kind of language you're using or anything like that, the execution mechanisms relies heavily on what you're using. Like if we were to use OpenMP, it would be the for loops and the static kind of method that goes with that. So being able to understand both sides of the fence when it comes to parallel programming is important. Being able to understand your system as well as being able to understand general ideas of parallel programming as a whole is important for us to actually implement when it comes to the programs that we're going to be using. So when we got to this point of the project, it was apparent that we have to really take our understanding of parallel programming to the next level. Take our understanding of OpenMP and our system with the Raspberry Pi to the next level. And I feel like it made us better as computer scientists.
Yeah, and also actually working on the ARM assembly. So the biggest thing we have learned this time is we are working on the conditional structure. For example, it's the if condition. How to make the code simply. That's the most that's the biggest thing we have learned, because we all learn the high-level language first. We can do on ARM assembly. We can do as the way we do on the high-level language like Java or C, but it might make your code super long. So the best way to simplify your code is to do the opposite way, like the high-level language. We only jump once on the conditional statement. Once it false, we go to the end, to the next part. If it's true, we just go through the code. You will find. Then your code will be shorter and it will be more efficient. How we can apply what we have learned in our future, like future job or academic life?
How can we apply this stuff in the future? I definitely think that what Aaron was talking about when it comes to the race condition is important. Immediately in this class, for the projects that we're using, understanding how to really do these programs, we have to actually go under the hood and see what's happening. You know, when you have a race condition, there are a lot of variables that we don't understand yet. So being able to go through the documentation, being able to understand how all these functions work and what exactly we're doing instead of just printing things out willy-nilly, it's necessary for us to make programs that are reliable, programs that are secure. And I think that understanding the race condition, like Aaron was saying, and understanding how to fight against that is the most immediate application of what we learned today.
In the first part of the parallel programming, we used something called the barrier pattern. So in parallel computing, barrier is a type of synchronization method. So for a group of threads or processes in the source code, any thread or processes must stop at this point and cannot proceed until the threads or processes reach this barrier. So I think this would help in
Race conditions. Because if you have that barrier, then it'll force them all to stop up to that point. There won't be a race condition because they'll all have to wait until they reach that point. Then they'll be able to continue.
or else
There
we'll
won't
come
be
up with errors and stuff.
exactly the timing issue will be solved because you made them all in time with each other.
Yes.
It would allow you to use dependency to a much greater extent as opposed to otherwise. So you'd be able to use parallelism much more effectively.
Yeah. So, what's our best or the worst experience or the challenge during this project? Yeah, the worst part is when we do the conditional statement on the ARM, we need to think opposite to our language because we all learn Java or C first. They are straightforward, but when you do ARM, it's the best way is opposite way. So then all your logic has to reverse. We need to do the opposite way. So when I simplify the code, most of the problem coming. So sometimes it make the logic completely wrong. So we need to pay more attention to that. Actually, we need to get used to that to think on an ARM assembly level.
Yeah, one important thing is you can't think. If you're writing in ARM code, you can't think in Java. You have to think in ARM. You have to think in that language. You think in ARM,
And-
in x86, x86.
And the best part I see in all the projects we've done so far, I mean collectively, is getting errors, right?
Thank you for watching this video. This is from a slice of Raspberry Pi. Thank you guys.
Peace out.
Okay, we're not done. We're still recording. So, check out the link. Go to that site. It's very important. Trust me. You're probably
Click the link.
Woody orders you to, and
Click it.
you'll probably enjoy
It'll be the best
it.
video you've watched so far today.
It's not
Yeah.
up to you. You're gonna click the link in about 5 seconds or so.
Please do.
By the time this video ends, you will already have clicked